Okay, I told you guys that I was going to be back, and here we are. I am back, and we are going to continue to move forward and look at this open source project. The goal with this project right now is not really to contribute or to even be able to understand everything. My immediate goal is just to see how does a large scale project actually work? What items am I unfamiliar with, and how can I become more familiar with them? Trying to look for those nuggets of knowledge that I can take in, understand, study, and improve myself to become a software engineer. So that's kind of the path that I'm trying to do right now. Now, in the future, we'll see how we can move forward and continue to progress. But as of right now, we're just trying to just see what we can find. So let me make myself a little bit smaller, and this is what we were, okay, so this is what we were going through, and I have this. Okay, so I asked the question, it said, want to see how this plays out in real animation processor or how frameworks use it to wire dependencies. So what we're talking about right here, in the last video, we were going through what does this, let me find it. Where did it go? Set of, was it in here? Ah, here it is. This get class, which is in the parent class. So this is the parent class where this is the parent class, abstract processor. And this class extends from abstract processor. And I was trying to figure out what does this get class actually do? And that's kind of how we went down this rabbit hole of many different topics. And one of those topics that we started to explore is um, how annotations are able to be accessed through the like metadata of the actual class. So I am trying to say it was up here where would you like me to, no, it's a roadmap. Want to see how this plays out. So here's where the question is. And I was asking about, can you give me some examples of how what might be useful? Oh, I was trying to understand that. All right, so real annotation processor example. All right, so I have singleton, okay, class my service, and then I have an inject annotation here. What happens behind the scenes? Annotation processor kicks in during the compilation. Okay, annotation processor. It scans for classes annotated with singleton and inject. It uses get class to inspect the actual class being compiled. Okay. It reads constructor parameters, field types, annotations. It generates a factory class like this. So my service factory, and then we have a method, public static, my service. So this is the type, build. So it's called build. That's the function's name. We pass in a context variable, context.getBean. So we're getting the bean of my repository, which is declared where? Here. Class, okay. And then we return my service here. Okay. This factory generated at compile time, so no reflection is needed at runtime. How get class plays a role. Inside the processor, class of any type, we capture it here, and then class.get annotation singleton class. Okay, why do we pass in a singleton class? And then we get back an annotation. This lets the processor dynamically inspect the actual class being processed, adapt behavior on annotation's presence, avoid hard coding logic. Okay. Framework example, Dagger, which is Google. Okay. Dagger also uses compile time annotation processing when you write component interface. All right. So far what I'm getting is that the annotation processor starts up, it looks for anything that's annotated, and then it puts that into an annotation variable inside of the class object. Okay. It's kind of trippy a little bit. I don't really want to see how to write your own mini annotation processor from scratch. I can guide you through building that. One detects custom annotations. How about we just keep looking here and see what we can find, and maybe we'll come back to it. So we have options here, which is a set, and then I can do add all. So I'm going to add, and then I'm passing in this right here. So this supported options, let's go there, which is part of the abstract class here. All right, here we go. So we're back to this location. So this is kind of where we went down that rabbit hole. So now we've recursed back up, and now we just popped out and we hit our base case, right? We're back. Okay, so we come in here, we do supported options, and I do this class, which refers to this class up here, this abstract injection annotation processor, okay? And then I say get annotations for this class, right? Which are none, okay? Supported options. Okay, so what is this supported options? Annotation processing. So this is within the Java, the extended Java language, essentially. So documented target retention, supported options, returns the supported options string value. Okay. So we're just going to come here, put this in, and say explain it. Explain this. All right. Okay. So this is the full definition of supported options annotation. So what I'm trying to do right now is understand this line of code right here. Like, what is this actual, what is supported options, this variable, actually going to contain? it's going to be an object, right, of type supported options, and it's going to get back this, but we passed in this class here, which is here. Public interface. I mean, there's a lot of stuff going on here. All right. A special annotation used in Java's annotation processing system. Let's break it down line by line so you understand what it does and how it's used. Okay? So, this, an annotation used to indicate what options an annotation processor supports. This annotation is used to declare which compiler options an annotation processor recognizes. These options can be passed in via the Java compiler or a tool like Gradle, okay? Let me actually read this. An annotation used to indicate which options an annotation processor supports. The @link processor #getSupportedOptions method can construct its result from the value of the annotation as done by abstract processor only. Here, strings conforming to grammar should be used as values, okay? And then authors, sure, whatever, okay, I don't know. So, @link, these references point to methods that use this annotation to determine which options are supported. If a processor class is annotated with supported options, the compiler can read those values automatically. And authors, okay. Meta annotation. These control how the annotation behaves. Documented, this annotation will appear in Java doc, okay? Target type, it can only be applied to classes or interfaces. Okay. Retention runtime, it is available at runtime so it can be read via reflection, okay? Public interface supported option. This defines a custom annotation named supported option. Now I remember something about interfaces that it's like not actually an object or something. I forgot about it. Can you explain more about interfaces, what they are, how they work, and an example. Okay. Annotation value. So this is the only element of the annotation. It takes an array of strings. Each string is a compiler option that the processor supports. So, supported options, my processor extends abstract processor. But that's not what we have up here. So I'm gonna say for number 2, I don't see anywhere that they have at supported options above the class of either the parent or child class. So how is it working? Okay, we'll let it do its thing and go back up to wherever we were. Okay, here, this tells the compiler my processor supports these 2 options. Okay, sure. So now, an interface is a contract. Okay. It defines what a class can do, but not how it does it. Okay, so it's just the methods available to me, right? I believe that was correct. Contains method signatures, but no implementation. Okay, so kind of like a prototype of functions within C, I think. Kind of like a H file. IntelliJava 8 plus added default methods. A class that implements an interface must provide a concrete implementation of its method. Okay, yeah, just like in C, where you can have a prototype in your .h function, but you need to then define what that function actually is in your .c. Interfaces enable polymorphism and loose coupling. Okay, so I already, on my little notebook, I have polymorphism as one of the topics I want to look up. Loose coupling. Loose okay. And then I'm going to say in context of interfaces. Okay. So I'm going to look that up too. So now we have an interface, which is animal, and it has this speak option. So and notice this is implements, not extends. So I think we implement interfaces. So I'm just saying that dog has to have something called speak, and we do right here. And cat has the same thing, and then I'm able to speak, okay? Animal is the interface up there. You can treat them as objects, okay. Why does get supported options work without this annotation? And this is a subtle but important point. What's happening is supported options, SO, equals this dot get class dot get annotation supported options class. This line uses reflection to check if the class is annotated with supported options. So why does it work? If the class is annotated, SO will contain the annotations of its value. Okay. If the class is not annotated, SO will be null and the method will return set of, just an empty set. It's safe and intentional. This method is designed to gracefully handle both cases. If the annotation is present, okay, I see. If not, it's just an empty set. Would you like to see how to write your own interface or annotation from scratch? Can you show me an example of how I can use these topics to perform annotation inspection. And then I'll say that is what we are doing, right? I want to see a more simplified version which you can explain the concepts to me. Okay. And I wasn't smart when I started making this video because I did not go and make more coffee. So that is unfortunate. I am all out. Okay. Well, we'll do what we can. Although it is what, 8 o'clock? So maybe coffee isn't the best, but annotation inspection is exactly what we've been exploring. Let's build a simplified hands-on example that ties together everything you've learned so far: annotations, reflections, get class, and interfaces. All right, the goal: inspect a custom annotation at runtime. Okay, so at runtime, we want to try to see what the annotations are. We'll create a custom annotation called info. So this is going to be defined by us. Okay, that's interesting. That's interesting, right? A base class that uses get class to inspect annotations. A subclass, let me just make sure that I have all of my definitions. Base class versus subclass. Which one is the parent? Which one is the child? A main method to run the inspection. Okay. So, step 1, define the annotation. So, retention is at runtime, okay? Target is just type. We went through that up there, but I still don't understand what that does. Important thing, public interface info. So we're saying that info has string author and string version. So 2 methods, okay? Retention runtime makes the annotation available at runtime so reflection can see it. Target type can only be applied to classes or interface. Are 2 annotation elements. And so this seems that we will need to implement it ourselves somewhere else, right? Because this is an interface, if I'm understanding things correctly. So create a base class that inspects annotations, okay? So base class should be what I'm thinking it is based off of the English. Base means the very lowest. So it doesn't extend, it doesn't inherit from anything else. That's base class. Okay, so the English does match up with what it actually is. That's good. Sometimes it doesn't work that way. For example, I remember static. I thought that the static keyword meant that it couldn't change, and I thought, well, static and const, they're the same thing. Because in my head, I was thinking the physics version of static, which is like statics versus dynamics. And so I was thinking, oh, well, statics are not changing. It's not the case. The English doesn't match up with the actual thing. But here, base class seems to match up, so we're good. All right, so class of any type, this dot class, get runtime class. for inspect, right? Info. So this is a interface. Class, get annotation, info class. So I don't quite understand how this is working because this is an interface, and why can we just do a method of class on info? For the inspector class, when you do this will return the class of inspector, right? Okay. Number 2 is here. Whoops. This info is defined as an interface. So how does it have a method of dot class? And I am not seeing where we actually define and implement the two interface methods in info, which are what? Name, third, and version. Okay. Question number 2. So, info.author, info.version, okay. Get class returns the actual subclass. Get annotation checks if a class has info annotation. Author here is me. So public class my component extends inspector, okay, here. So now I can run the inspector. So public class main. So now I do inspector object here of my component here. So I create this new component, and then I can do object and then dot inspect will detect info. Okay. So concepts are annotation. Maybe I should say custom annotations is another thing that I want to look up. Okay. Runtime inspection. Okay. Inheritance, reflection, or inspection. Okay. All right. So I'm gonna ask this. I feel like right now I'm kind of running. I need to go. I've hit the point that okay, I found enough topics that going through and slogging through more here is not going to be helpful until I go learn about all of these things which I have. So polymorphism, reflection, Java generics, type erasure, Java lang object, Java annotation in processing, or Java annotation processing tutorial, Java C annotation processor, class loader, loose coupling, base class versus subclass. We got that though. Custom annotations and runtime inspection. So I think I kind of need to go and look at those and then come back here. So that way I can make even more progress, accumulate. Once I understand those, I'll be able to go and move the frontier, grab more stuff now that I don't understand, and then collect those and bring it back and try to learn those. Should we look at this? So does return inspector, not necessarily, it determines on the object you're calling. So this one is going to be main? I don't know. So how does info class work if info is an interface? And where are its methods implemented? Class.info is valid because in Java, annotations are interfaces under the hood. When you define an annotation like this, you're actually defining a special kind of interface that the compiler and JVM treats as metadata. So what info.class means, it refers to the class object representing the annotation type info. Class object representing the class type, okay? You can use it to query annotations via reflection. This returns an instance of the annotation if present. Okay, so yeah, I think what I'm gonna do is I'm gonna go and I'm gonna start watching videos on those topics right there. I'm going to try to understand them, and then once I get to a point where I have at least some understanding of these ones, then come back to this and try to continue, make progress, and learn what we can. So if that is interesting to you, subscribe to this channel. I would love to have you around. My name is Timothy Lee Grant, and I will see you guys very soon.